Hello, hello. I'm ready with my presentation here. Good afternoon to all. This is Sai Prasad, research scholar at KL University, Guntur. So today I'm here to present my paper titled "In a Novel Subset Feature Selection Framework for Increasing the Classification Performance of Sonar Targets." So the major area of this paper is data mining, and the minor area or deep area of this current paper is feature selection. So in this paper, I would like to address one of the key pre-processing issue, that is high dimensionality, and we have tried to propose a new framework for feature selection. And here we have applied our framework over the sonar dataset. So the abbreviation of the sonar is sound navigation and ranging. So as I said earlier, my major area of research is data mining. So we know that it is an interdisciplinary field of study, generally used for extracting the knowledge or extracting hidden patterns from the available large amount of data. We know that data mining can be applied in many fields, including healthcare or social network, business, stock market, sports, or many. So the same data mining technique here we are going to apply over the sonar data sets. The full form again, it is a sound navigation and ranging. So next thing is, so we know that generally data mining, it is not a direct stage. So there are various stages we need to undergo for getting hidden knowledge. So the first step is the data gathering or data collection, and next is the data pre-processing. Then after that, apply some intelligent data mining techniques for getting hidden knowledge or hidden patterns. Then analyze the result. Then visualize it for proper understanding. So these are the basic steps in the data mining. So our focus is addressing the one of the pre-processing issue. So that we will see in next slide. So these are the some of the data mining techniques, intelligent data mining techniques. So the association rule mining, classification, regression, clustering are few data mining techniques. So the classification is again our major focus here. What is the association rule mining? This is used for transactional database for getting or for knowing the frequent items or frequent patterns. So next, regression and classification, generally it is used for predicting some unknown thing. Clustering is used to group some data items or data points based on some similarity. In this, again, we are going to focus more on the some of the classification algorithms like a rule-based, tree-based, naive-based, and lazy learning. So we have applied our framework for the using the some of the rule-based algorithms and some of the tree-based algorithms, some of the naive-based algorithms, and some of the lazy learners that we will see shortly. And as I said earlier, our major focus is addressing the one of the pre-processing issue. So generally, gathering or gathered data may have a different issues. One among them is the noisy data, or it may have some missing values. So if the data is having noise values or outliers or missing values, so we may not have a accurate result of. And next, the collected data, it may have some mislabeled. There may not be a label for an instance. And next, data may suffer with this imbalance. What is it imbalancing? Imbalancing is nothing but so having some disproportionate rate of the instances. So that is what the imbalanced. So in addition to this noisy, missing values, mislabeled, imbalance, there is another issue that is called high dimensionality. So the collected data may suffer with this high dimensionality. So what is high dimensionality? High dimensionality is nothing but having a more number of features or variables in the collected data. So what happens if we have a high dimensional data? What happens exactly? So what are the problems or what are the drawbacks associated with this high dimension high dimensionality? So now, so if the all the features or variables in the data set are considered, what happens? So if the all the features variables in the data set may not create a better classification model. Uh, Instead, it may create some confusion to the learning model, and also it may degrades or lower the classification performance. And another issue is if more number of features or variables are existed in the dataset, it consumes the more memory while creating or generating a classification model. So all the features or variables in the dataset actually may not required. Some may be duplicate or some may be redundant. So our ultimate goal is we have to identify the duplicate variables or redundant variables. So how we can address this issue? So this high dimensionality can be addressed using the feature selection or feature extraction techniques. So what is feature selection and what are the some existed feature selection methods are there? So here again we have concentrated on the feature selection, not feature extraction. Feature selection is nothing but selecting some best features among the available data point variables. Feature extraction is nothing but getting the subset of the features. So there is a huge difference is there between the feature selection and feature extraction. So what are the existed feature selection modes are there? So there are generally three types of feature selection modes are available in the literature. So one is the filter based, wrapper based, embedded methods. So what is filter based? In a filter based approach, rank will be given to the each feature based on the worth of the feature and the information that is associated with a feature. So actually the filter based methods are based on information theory, and this information gain ratio, relief, chi-square attribute evaluator, symmetrical uncertainty. So these are the some of the feature filter based feature selection method. As I said earlier, it assigns a rank to the each and every feature. So depending on the need, we can select the top features. So the top feature will have a highest weight and the last feature will have a lowest weight. For example, if we have a 50 features in the data set, all the 50 features are not required. If we want to select only 10 features, which 10 features we can select? So what we can do, we can apply the any one of this filter based technique, and so that it will give the or a rank to the each feature or assigns a rank to the each feature. So the based on the requirement, we can pick up the top n features. So if out of 50, if you want to select top 10, apply this information gain or gain ratio. So as per its rank, select the top 10 and apply any classification technique. That's it. Now we can get a better result. We need not to uh, consider the remaining 40 out of 50. So that is what the filter base. So here we have used symmetrical uncertainty as a key criteria for creating this proposed framework. So the reason behind this symmetrical uncertainty is the symmetrical uncertainty is derived from the mutual information by normalizing it to the entropies of feature values or feature values and target classes. And this symmetrical uncertainty, it, it is a measure of correlation between either two features or a feature and the target concept. So that is the reason why symmetrical uncertainty is used. Of course, there is no much difference between the information gain and symmetrical uncertainty. And remaining this other filter based technique like information gain, gain ratio, relief, chi-square, we have used it to compare the proposed methodology. And another filter feature selection mode is wrapper mode. So what it will do is it derives the subset of features. So, and how it will derive the subset of features? So it use the some kind of searching algorithm, that may be genetic algorithm, that may be a breadth first or sequential forward or sequential backward, something else. So it is a time consuming as well as a costly, but it will give the accurate then filter based. Then next one is embedded. It combines the both filter as well as the wrapper. Well, so now this is our proposed methodology. Actually, it is our proposed methodology is inspired from the project allocation strategy that is used in academics for creating a student project batch. So generally, how the project batch can be formed. So depending on the project size, actually students can form their team as per their choice. It means same kind of students, means similar kind of students can be in a one batch, or all top ranked students can be in one group, or all weak students can be in a one group. So if this is the case, a group with top students can get better quality project, and the outcome of the group with a weak students, they definitely their project quality will be very low. So if a project group, here I am calling the group as a cluster. So the cluster can be formed in a proper manner by mixing top ranked, average rank, and low ranked students. Project quality can be improved, and weak students can learn some knowledge from the top ranked students. So based on this idea, we have proposed this methodology. So as I said earlier, the key criteria is the symmetric uncertainty. We can use instead of symmetric uncertainty, we can use any other filter based also. The result may be vary. So the first step is first get the rank of rank and symmetric uncertainty value of each attribute, and ignore the attribute whose symmetric uncertainty value is 0, because it cannot give any extra strength. Then third step is order the all attributes in decreasing order of their rank. Of course, by default, all the features are ranked in a decreasing order. That is, top feature will have a top rank, and least weight feature will have a least rank, obviously. Next, define how many number of clusters or groups you want to form. Then calculate the how many features in each cluster can be accommodated. So here, if m is the number of cluster that you want to form, if n is the number of features, so total there will be a fc clusters. And the next step is this is the important step here. Arrange the first fc number of features from the list left to right direction. Next step is arrange the next fc features from the list right to left direction. This is the only very simple idea behind this. First arrange it in left to right, then right to left. Repeat step 6 and step 7 until all the features are arranged. So first we have to do first left to right, then right to left, left to right, right to left. This we have to keep on continuing until all the features are arranged. After this, we have to form the groups or clusters. How? That is all vertically first order features into the first cluster, second order feature into the second cluster, and so on. So sometimes all the features or all the clusters may not have a equal features. So what to do? Then remove the last feature from the cluster which has a more features. Then stop. Let us see one example here. Assume there are 12 features, and out of 12 there are only 10 features whose SU score is greater than. I want to form a 3 cluster. So how this can be? So assume these are the 10 features whose SU score is 10. So I want to form the 3 clusters. So first 3, A1, A2, A3, that is in left to right direction. A4 is the next one, so place it in a right, then A5, A6. So now this you form it in a right to left direction. Then again, this is step 6 as per the algorithm. A7, A8, 9, then A10. So this is the way, first left to right, right to left, left to right. So this we have to keep on continuing until all the clusters are formed. So now group the first order cluster in a first order features in a first cluster, that is A1, A6, A7 will be in cluster 1, this A2, 5, 8 in a second, 3, 4, 9 will be in a. So here we have to note down that A10 is an extra cluster, extra feature in this cluster 3, so that need to be discarded. So anyhow it is a last ranked feature, so that may not consider, that may not give any extra strength to the classifier. So let us see the actual experiment. So this framework it is applied on the sonar dataset. Initially there are 60 features. So after applying symmetric uncertainty, so there are only 21 features whose score is greater than 0. So I have tried to form the 3 clusters, 4 cluster and 5 clusters. So here as per the first step, first we have to get the rank of each feature and their symmetrical uncertainty score also. In addition to the symmetrical uncertainty, I have applied the information gain ratio chi-square relief on the same dataset. Here we can note that we cannot find same rank to the every feature. See here you can note that here 48 feature is having rank 6 when it is applied on SU, IG, chi-square, whereas with this gain ratio 54th feature is having a rank 6. So there will be some kind of deviations here. So these are the last complete 21 features. Out of 60 there are only 21 features whose score is greater than 0. So next I have tried to form the 3 clusters. So as per the algorithms, so this is the result of a feature with 3 clusters. So I have given ID IS31, 32, 33 something like. So there are 21 features. So 21 features are divided into 3 clusters. So each cluster will have a 7 features. So now how to test the worth of the each and every cluster? So for this what I did is I have considered the top 7 features of the features derived by this information gain ratio, chi-square and relief. So this we can see from here. So these are the top 7. These are the top 7 GR. These are the top 7 of this thing up to 7. Okay, similarly, I have formed the 4 clusters also. So with this, each cluster will have a 5 features, and last cluster I think it will one will be discarded because there are 21 features. So 21 by 4 it is 5. So one extra feature is that has to be discarded. Similarly, these are the feature derived features with the 5 clusters. So now as I said in introduction, we have used some classification algorithms for testing our proposed methodology. So we have used these uh, rule-based techniques JRIP 1R rider and tree-based techniques J48 and simple cut, and base learner naive Bayes and lazy learner KNN. So now if we observe the result with in case of ZRIP, this second cluster is competing with the some of the traditional techniques like a chi square, GR, that is gain ratio, and information gain. It is ranked second. Whereas in case of this J48 simple cut and naive Bayes IS3, that is third cluster, is performing better than all the existing. So if we can observe the features with the clusters, so IS31, 32, 33 are the features formed by the existing. These are not having any repeated features. So all these clusters are having unique features. So similarly with this 4 clusters and 5 clusters also. And this is the result of the result analysis with the 4 clusters. Here we can observe that 1R is doing better than all with this IS42, that is second cluster. Next here J48 rider is doing better with this IS43, and simple quad is doing better than all other, and here IS42, that is second cluster, is doing better than the remaining. So this is the result of the cluster analysis with this. Next this is the result analysis of this 5 clusters. So now finally I would like to conclude that here we have tried to propose a novel cluster of feature selection and ranking methodology. So the proposed framework is evaluated using real-time sonar dataset. So with this framework, what exactly happened is we have tried to form some unique number of candidate subset of attributes, so that each subset will have a least number of features without any duplication, and all the subset of features are analyzed with some of the classification techniques and compared with the existing filter based feature selection. And finally we have given the ranking to the each subset that is formed by proposed method. So the displayed result have shown that one of the subset, in some cases more than one subset, have registered a better accuracy than existing methods. So with this, we would like to conclude that instead of choosing the feature extracted by already existing methods, depending on the need, the proposed framework can be used to form the subset of features for better prediction accuracy. So what is the advantage of this? So in this study, we have considered actually 3 clusters and 4 clusters, 5 clusters. So with this, what happens? So respectively 33%, 25%, 25% of features can be selected maximum. So thereby training time and memory consumption for model generation can be decreased. Actually, the same thing we have tested with 9 more data sets. So in all the cases, the result is same. So it may actually varies depending on the data set that is we consider. So this is what my presentation about this. Thank you.